I'm Dr. G4, and welcome to Proto-Future, a podcast about SEO optimizing episode titles to push leftist agendas in hobby spaces. This is episode 19, How to Model Modern Transit Part 2, Passenger Trains on Shelf Layouts. In this episode, I'll expand on modern transit prototypes to address how they specifically interact with and improve model railroads. Last time, I discussed from a prototype perspective the technologies I'm calling modern transit, those being walking, bicycling, streetcars, trams or straßenbahnen, light rail, stadtbahnen, tram-trains, DMUs, S-bahnen, intercity trains, night trains, HRSR, and HSR, along with legacy options like buses, heavy rail, and Amtrak-style long-distance trains. This episode is going to be different from the last in as much as it will address why and how I think these developments in municipal infrastructure, politics, and intergenerational anti-car conflict directly influence model railroading, not only in terms of modeling the built environment, but specifically by affecting, and I would argue improving, model railroad operations. Finally, in part 3, I'll discuss layout design for modern transit operations, giving ideas for how to include each of these on layouts small, medium, and large. So, going back to the modern transit landscape, bottom to top, let's reinterpret them for what they mean for model railroading. Unfortunately, as I can exhaustively report from my own explorations of everywhere from Dallas to Seattle to Boston to Los Angeles to Orlando, walking is straight up ostracized in most suburban areas by, quite simply, failing to provide a sidewalk, which is the major reason for influencing my decision to leave the US. However, that desire paths continue from the end of the concrete reveals that people still like, or have to, walk there anyway. So let's fix this. Let's all vow to never build a model road without sidewalks, no matter how rural it is. In some cases, say a rural highway, you can separate the road from the sidewalk by making it an adjacent multi-use path, but still running directly enough to be used for transportation, not just recreation. Multi-use paths, or MEPs, also follow other rights-of-way, not just roads, and, increasingly these days, asphalt and gravel trails parallel railroad tracks for very long distances into the woods. If you're modeling urban areas, separate the sidewalk from the road by a row of planters with trees. This improves pedestrian safety by putting a natural sylvan barrier between the innocent sidewalk users and the malicious vehicular homiciders. Also, let's try to outrightly obliterate model parking lots, and narrow roads to never more than 2 lanes. All excess road width should be dedicated to microparks, green space, streeteries, wider sidewalks, or cycle tracks. If you ever model anything 6 lanes or wider, you're a car-brained psychopath. Give your layout a road diet immediately. Walking infrastructure is present in practically every major urban area, near not just Union stations but also some suburban ones, as trains have a habit of creating a ton of pedestrians in their wake. Exceptional examples of train-adjacent walkability include many stations of Chicago's Metra, Philly's SEPTA, and basically anywhere on the East Coast or Midwest where the train stations were built prior to automotive indolence. As far as models go, I don't think anybody has made a proper, modern, ultra-wide urban sidewalk, but at least plastic and laser-cut wood models of narrow sidewalks exist, and if you're the person to make your roads out of plaster, making a wider sidewalk is trivial. I'd also recommend for realism varying the concrete color in geometric patterns, as modern architects love lines and different colored shapes crisscrossing a plaza, sometimes even with unique asphalt effects like sparkly material, faux form or street trackage, or even hydrophobic paints which reveal artwork when wet. Additionally, street details like planters, benches, handrails, and trash cans are scattered absolutely everywhere in modern pedestrian spaces. I am overwhelmingly certain that bicycles will be as important to the towns of the future as cars are to the towns of today. And similarly to walking, prototypical bike infrastructure is much more extensive than anything depicted presently in modeling. In essence, on absolutely every road you model, there should be a high-quality rubber and flexi-post or full-on concrete curb-protected green thermoplastic cycle track, ideally bidirectional on one side of the road if not both, taking up the width of a car lane or more. Importantly, bicycles should have an absolutely comprehensive network. Don't allow cycle tracks to end abruptly. Add green thermoplastic bicycle routings through every intersection, and make it such that any bicycle could travel safely around any of your roads to any other destination. Anywhere that a nasty criminal car could go on your layout, so too should a bicycle have its own safe route protected from that automotive evil, no exceptions. Outside of cities, there should be comprehensive bike trails. Maybe next to the tracks, maybe on the other side of the river from the tracks, maybe built out of old railroad grades, and maybe even using spontaneous flyover pedestrian bridges to get from one side of the railroad grade to the other, or to access nearby towns. I'm particularly thinking here of several segments of the Gap Trail just southeast of Pittsburgh. From experience, I can say that these long-distance trails are used at least equally by locals walking and biking on a day trip or to work, as much as they are long-distance touring bicyclists. The best bike trails are both well integrated with local towns to access their amenities, as well as frequently hosting amenities of their own in the form of free hiker-biker campsites and frequent picnic areas with benches and tables. Finally, long-distance bike trails are often deeply integrated with trains, both commuter and regional routes, as well as intercity and long-distance trains. Two of the most famous bicycle routes in the country, over 300 miles long, the Gapco and the Katy Trail, both parallel Amtrak routes and visit almost every station for ease of transport logistics. I even believe the Katy Trail is so popular for bicycling that the Missouri River Runner has to run with 2 baggage cars to accommodate all the bicyclists. A notable third category of bicycling is the concept of car replacement cargo bicycles. The two major types of cargo bicycles, longtails and Bachfeets, are currently almost entirely absent from hobby manufacturing, even 3D printing specialists like Mini-Prints. The closest I've found is a cargo tricycle from Magnorail, which I'll discuss in a moment, but as far as urbanism goes, any properly urban environment should allow you to live fully without a car. Part of that involves allowing larger capacity bicycles, and therefore this means 2 things. You should build your bicycle infrastructure to be safe and allow long wheelbase bicycles, and you should buy 100 model cargo bicycles the moment a manufacturer offers them in your scale. In some cities, even US ones, cargo bikes are well past 10% of all bicycles on the road used for commuting, and bicycles everywhere are rapidly approaching 10% of total travel mode share. One of the most unique things about scale biking of late has been the company Magnorail, which makes animated bicyclists complete with moving legs. This allows for the obvious fun of miniature bicyclists cranking their way around the layout, thereby adding an obvious degree of animation and movement outside of the trains, and for a hell of a lot less difficultly than the animated automobile systems. However, importantly, this system operates by way of a sunken plastic track for a chain with periodic magnet attachments, and thus requires creative thinking to deal with the limitations of a chain drive system. It's better to have fewer and shorter chains to look after, so to maximize each chain, you could possibly model a single major bicycle highway. For my own layout, well, before I packed up and started fleeing to the EU, I imagined a long, contiguous 20-foot route that wrapped around a peninsula, turning from a trail into an urban cycle track, with turnarounds at 2 separate bicyclist-only roundabouts connecting to modeled but unanimated trails leading off in different directions. Alternatively, individual segments of bicycle highways could be animated in smaller chunks, but either way, whatever ends up being animated should likely be restricted to high-traffic main routes for the greatest return on effort and minimizing the obvious delineation between animated and not. Some of the better examples of modern bicyclist infrastructure, especially adjacent to trains, include Minneapolis, New York City, and even to an extent DC and many places in California. As far as modeling goes, nobody has yet made kits for green thermoplastic cycle tracks, but this could be replicated either through painting with an airbrush or trial and error coloring, casting, and plaster, the same way as many model roads. However, if you're willing to deviate to either asphalt or unprototypical for America but prototypical for Europe red cycle tracks, I believe either Faller or Knock makes long adhesive bicycle lane strips for use either alongside roads, bad, or as independent cycle tracks, good. Buses are a form of transit that I inherently think is unwoke because any lane used by a bus is one which could also be used by a car, which is bad. So any exclusive right-of-way which is used by a bus would better be used by light rail instead, and buses are better off not existing. But, given that this is the world we live in, and for some stupefying reason, most people are not as much a train extremist as I am, I can imagine several types of bus-specific infrastructure which others should be aware of and integrate onto practically any layout. First off, the simplest way to model buses is to just actually model the damn buses. Put bus shelters, not signs, around your roads at strategic locations, and be sure to get a large cadre of buses when you buy vehicles for your roads. This is so easy and cost-effective that practically anyone with a scenic layout could do this right now and have a Woker model transit system across their entire layout in less than a month's worth of evenings. In terms of more bespoke bus infrastructure, consider modeling a transit center, especially at passenger train stations, to facilitate multimodal transfers. A transit center is a large bus-only circus with many sawtooth bus bays on a concrete island and sometimes with a park-and-ride parking garage nearby. However, a transit center could also be as simple as a stretch of road with 2 bus bays on each side to handle higher-than-conventional bus route stoppages and clearly designate whither each route departs from and goes to. Take a look at downtown Kirkland, Washington for a prototypical example of this minimalist arrangement, also conveniently not too far away from a hobby shop. Consider a transit center like a major industry generating traffic, but for passengers. It doesn't matter how little walkable urbanism you've modeled on your layout, putting a bus transit center at a train station implies that there's a huge amount of stuff just barely off layout, and justifies a large amount of passenger traffic along the entire length of the railroad. Finally, at the top end of bus infrastructure is bus rapid transit. BRT is basically a bus-exclusive right-of-way, usually with slightly larger and more elaborate stations, direct routes into downtown, and periodic dedicated ramps or flyovers that allow buses to join from regular roads and bypass major congestion points. Now, I personally think that BRT is also a complete scam, as it gets you a much lower return on investment, having neither the low cost of a regular bus nor the high quality of rail transit. But what is of note is that some, possibly even many, BRTs actually run immediately adjacent to railroad rights-of-way for long distances, basically in the form of a bus and emergency response only roadway that parallels train tracks for long distances. Major examples of railroad-adjacent bus infrastructure include Hartford, Pittsburgh, and Fort Collins, with cities from San Diego and Eugene to Calgary and Houston also having many train-adjacent transit centers. For modeling, iconic replicas make spectacular HO-scale modern and recent buses, both regular and articulated, and with prototypical paint schemes from almost every major city in the US and Canada. And many manufacturers, but particularly Walthers, make simple kits of modern bus shelters. Streetcars, as they currently exist in the US, could be argued are largely failures at ameliorating car dependency. However, several extremely successful systems do exist, including Kansas City, Cincinnati, Portland, and, to a lesser extent, Dallas, M-Line, not Bishop Arts, Seattle, and Milwaukee. However, of note, almost every single modern streetcar has a station immediately outside of their city's Amtrak station, including Kansas City, Detroit, Oklahoma City, Dallas, Bishop Arts, not M-Line, New Orleans, Seattle, Tucson, Charlotte, Milwaukee, and until recently, DC, fuck Muriel Bowser, and all not extreme leftist Democrats. The saving grace of North American streetcars from a modeling perspective is that they are usually infrastructure light. Very few turnouts, usually sharing a traffic lane with cars, often with operations and maintenance facilities, or OMFs, smaller than the size of a single city block. Furthermore, there are several tourist-targeted streetcars in places such as Dallas, M-Line, not Bishop Arts, Little Rock, Tampa, St. Louis, and formerly Memphis and Seattle, which have been operating admittedly more as downtown decoration than actual transit, but at least for a very long time, such that if you model any Union Station anytime after the 1970s, there's a decent chance you could justify a streetcar right out front of it, even deep into the automobile era. If you were willing to proto-freelance a little bit and wanted to model a better streetcar, basically any decently major urban roadway anywhere near the main train station on your layout needs to have a streetcar on it. If you can figure out a way to make a streetcar or two shuttle back and forth between a visible station and a tiny holdover track behind the backdrop, then there is no excuse to not have a streetcar on your layout. As far as vehicles go, several close models have been made in N-scale, but no modern American vehicles have been made in HO. Historic vehicles suitable for the heritage streetcars aforementioned are available aplenty, but presently modeling anything in the past quarter century is relegated to 3D printing or kit-bashing models from European prototypes, which, all things considered, aren't overwhelmingly difficult these days, especially by taking a model of a Euro tram and just shortening it by a few articulations. Trams, oder Straßenbahnen, sind jedoch ein level up from North American prototypes. In a sense, these might actually be easier to model because they are so much more expansive, whereas an American streetcar is a small shuttle carbuncularized onto an Amtrak station, a proper tram system has many branches and termini. This allows two things. Firstly, any station decently urban or suburban anywhere along the layout could have a tram stop. It doesn't have to be the Union Station. And secondly, this pervasiveness means that it doesn't necessarily have to be a contiguous or even operating system. If one tram stop at one station isn't operating and just quickly goes on and off the fascia, but if there's a different tram line at a different station nearby that is animated, the limitations of animating individual scenes would hardly be noticed. A more pragmatic difference, trams typically also have turnback loops, much higher frequencies, and variable service stopping patterns. Thus, especially for the novice modeler, it is always an option to model a much easier continuously running loop-to-loop tram system as opposed to the modern American streetcar, which has tuning fork reversing maneuvers and spring switches at each end. While programming station stops of the streetcar is ideal, it's more forgivable to not have for simple loops than for reversing shuttles, just so long as the dedicated stations are actually modeled. Euro-style trams are also significantly easier to model given the plethora of model vehicles available from, of course, European manufacturers. A wide number of model vehicles exist of paint schemes so obscure to the American modeler that a fantasy paint scheme is practically unnecessary, and they come in so many different shapes and lengths that whichever individual model is purchased merely comes down to personal preference. It's a rare instance of, I think that one's pretty, being an actually completely viable proto-freelancing strategy. I most enjoy the work of Halling models based out of Vienna, as they offer innumerable, beautiful models with well-hidden drives in DC and DCC, although I don't think they have sound yet, for a ton of prototypes all across the continent, of Europe, of course. The only downside is that you have to arrange with your bank for a money transfer, which can be a bit complicated, but I've done it successfully myself and now own one of their ultra-petite Vienna ULFs, so if I can do it, anyone can. Additionally, many manufacturers offer pre-made snap-together street trackage in multiple scales and large complicated track arrangements, so whereas a streetcar requires bespoke track work to look realistic, for a tram you can just go ham, and anything unnecessarily overcomplicated, hinting at a much larger functional network beyond what is presented on the layout, would actually look fully prototypical, while also being easier to model. Up until recently, modeling light rail would have been a very, very difficult exercise, involving lots of scratch building or 3D printing. However, with Bachmann finally announcing the production of their S70 and S70 US LRVs, the first major hurdle is finally over. Any moment now, one will finally be able to buy a light rail vehicle, ready to run with DCC and sound, putting fully prototypical modern transit into the hands of literally any modeler. Station platforms can be readily adapted from a wide variety of European kits, addressing another major difficulty in construction. Unfortunately, modeling a whole light rail line end-to-end, even an artificially small one at 4 or so stations, is probably at best the realm of a huge club layout, but that doesn't mean light rail doesn't have a place on medium or small layouts. In almost every instance, light rail systems share at least a small portion of their right-of-way with freight lines as a quick and easy corridor requiring minimal demolition. As such, at a minimum, practically any layout set in modern times and an even remotely urban or suburban locale could justify a brief section of double-track LRT paralleling the freight main line, with hidden returns at either ends as either a true double-track loop or a dog bone with turnbacks. Hell, you wouldn't even need to model a station to successfully pull off the cameo, simplifying construction by modeling only a length of LRV mainline without the difficulty of station stops, just high-speed LRVs pacing the freight trains. Overall, of all the modern transit systems requiring reserved rights-of-way, light rail is probably the easiest and simplest to pull off, and can realistically pass as the modern equivalent of a token non-stop streetcar loop, but this time being actually prototypically accurate and not dinky. This also works for light rail systems with underground stations, being the modern, actually prototypically accurate variant of the token dinky subway loop below ground just as much as the trolley loop above. If you want to up-level things, obviously you could add a station and program the vehicles to stop at it, but additional levels of LRT sophistication could include surface light rail lines serving Union stations by street-running reserved lane trackage out front, or more rarely, sharing platforms with the Amtrak and freight trains out back, as is the case with Dallas or Sacramento. Okay, well, Sacramento sort of, but that's another story. On the distal end, a programming challenge but animation delight would be a double-track tuning fork turnback, where the LRVs would automatically appear out from behind the backdrop staging area, take a double crossover into the unoccupied track of a terminal station, and then the switches automatically throw, and the LRV that was waiting on the opposite track of the terminus then automatically departs back out to staging, and all of this would happen on a scale schedule of every 10 to 15 minutes. Obviously, any one of these layout design elements could be made contiguous in a cohesive multi-station self-operating rail transit system, or together but physically isolated as vignettes for sake of simplicity, or even just as a single individual standalone scene depending on what your prototype is, or if you're proto-freelancing, because that's the space you've got. However, I would like to highlight here that this is where there is a chance to finally graduate from an operating paradigm of run it in a circle or back and forth stopping at stations like a model bus driver. If you were really adventurous and wanted to add an operator position, you could model an OMF, or an operations and maintenance facility, and give it the operator position of a hostler. In this case, the main line could still be automated for trains stopping at stations and reversing directions, but a human operator would be responsible for hostling LRV lash-ups, dispatching trains out onto the light rail main line in the morning, taking some off the main after the morning rush, sending more back out for the evening rush, shuffling off-duty LRVs in and out of maintenance bays for routine service, running maintenance trains overnight to repair track and cut back plants, and potentially even arrange single tracking in the event of a maintenance or a randomized service disruption. Depending on your fast clock and the size of the setup, the light rail mainline dispatcher interfacing with the automatic operation software and the hostler could either be the same or two separate operators. So long as normal operation sessions on normal layouts have locomotive hostlers, I see no reason why an LRV OMF couldn't offer an equivalent level of entertainment for op sessions, while also advancing the prototypicality and visual distinctiveness of the model railroad. Moving a level further up to Stadtbahn, in part because it's so truly rare in North American context, I don't think there's anything more to add beyond the light rail section other than more. More large, complicated junctions, more mainline passenger stations around the region also served by the Stadtbahn, not just at one central location, and overall, more Stadtbahn and running around more of the layout. But getting light rail into modeling is already a Herculean task in itself, so I won't belabor Stadtbahnen anymore. Now, heretofore, modern transit has been entirely sequestered from mainline trains, in part because, even forgetting about tight curves and loading gauge, you don't want freight interference to humongously delay trains used for everyday commuting, and transit vehicles coming every 20 minutes or better couldn't provide a realistic slot for a slow-moving freight train to get through. So even if things like freight trains and light rail run side by side, their tracks are almost never interconnected except to occasionally swap maintenance vehicles. However, with the advent of things like tram-trains, DMUs, and S-bahnen, now modern transit shares the same rails as freight trains, and is capable of directly interfacing with freight trains in a way that benefits model railroad operations. You could have a regular op session on a regular switching layout with one of a few regular freight trains, or, for minimal scenic changes, you could have all of that and a passenger train coming every half hour each way, requiring you to clear the main line. For almost the same amount of effort laying track, the layout goes from, say, 3 trains in operating session to 43, on a shelf switching layout. I know which one I'd find more fun, and that's why I'm such an exuberant and uncontrollable stan for modeling modern transit. So, let's look at this through our next transit mode up the list, tram-trains. Unlike DMUs, which have a strong prototypical basis in North America, tram-trains are completely illegal, because the FRA incorrectly chose to use PTC and thereby gargle Wabtec's balls, because Buy America! And as such, the US does not allow the mixing of light transit vehicles and heavyweight mainline vehicles like as is possible under the European Train Control System, or ETCS. However, what's a little proto-freelancing away from fascist American policies? Since it should be the case that light rail can extend its reach onto main lines to offer better regional rail service, why not just pretend that it is that way anyway, and build our layouts to suit? Why do we need to wait for reality to catch up to model something when reality is so obviously wrong? In pursuing that philosophy for tram trains, we actually find a paradoxical phenomenon to much of modern transit. Since tram trains use tram tracks to get at the core of a dense urban agglomeration, a tram train primarily interfaces with freight railroads outside of the urban area, joining up with the freight tracks on the edge of the city and carrying on to serve a few smaller outlying towns before ceding the rest of the railroad to freight again. Maybe think of it like a light intercity passenger train that just ducks out of the main line right away before getting to Der Hauptbahnhof. Now that I think about it, we actually do kind of have something barely similar to a tram train in the US, SEPTA's Lansdale-Doylestown line. All stations are small, rural, stretching the gamut from suburban to exurban to towns and villages, served infrequently by S-Bahn standards, but there is a major freight yard in Lansdale, and the freight trains I believe share the track with the electrified regional partway into Philly before diverging to take their own route through the city as the passenger vehicle heads off to 30th Street Station. So, minus the fact that these are overstaffed high-floor vehicles, if you just swapped in low-floor light rail, it would be extremely similar to what a tram train would look like in a US context. The one downside to modeling tram trains is, of course, the overhead wire. Modelers are famously loath to install catenary, both for aesthetic purposes as well as the sheer difficulty of dealing with such small and delicate parts. Since catenary doesn't change the loading gauge, you still could run absolutely everything on a mainline railroad you could under a catenary wire, double stacks included, but it's still a lot of extra effort to put in, especially if you're coming from a diesel operation, which wouldn't have needed catenary wire at all. What you could do as a light compromise to just get some tram trains in operation with minimal effort would be to have a brief intersection, maybe only 10 or so feet of shared mainline. The tram can pop out from staging behind the backdrop, disrupting the freight mainline for a moment as it stops at a single station on the shared line, then just as quickly leave the shared mainline for a terminus station on the streets of a small village nearby. This is effectively a modern passenger version of some famous railroad interlockings in the Midwest, where a 4-track mainline was crossed by a smaller line at a very oblique angle, using turnouts instead of diamonds, so that trains from opposing railroads were effectively sharing mainline occupancy for a very short distance. While not at all prototypical, this could actually be a very viable proto-freelance for someone who likes the aesthetics of light rail vehicles, but either doesn't model a dense urban area or wants to model light rail in a way that more directly interfaces with traditional freight rail. This will become especially prescient as soon as Bachmann releases its Siemens S70 LRVs in a year or so, and a lot of people buy them because they're cool, but then don't know what to do with them next. Whereas tram trains are largely fanciful at the moment in North American contexts, DMUs are an entirely prototypical way to bring frequent transit to the same rails as freight trains, with a dozen examples and counting in North America. Officially, Byzantine FRA crashworthiness standards generally still require heavyweight freight or intercity trains to be separated from lightweight transit vehicles, which results in either physical separation, with redundant transit-only tracks adjacent to the mainline tracks, similarly to light rail, or uniquely temporal separation, wherein freight trains run at night and passenger trains during the day. Although I will note that both are often used in tandem on different segments of the same line depending on adjacent freight volume. Taking this at face value, you could either run a full 24-hour clock, having switching tricks at the beginning and end of operating sessions punctuated by running passenger trains in the middle, or, more likely, and my preferred methodology, you could just use your modeler's license to completely fudge the FRA and have freight trains running around the DMUs simultaneously, as they do over in first world countries, seeing as the US has now been downgraded to post-Soviet. I personally think that DMUs have outrageously revolutionary potential for model railroad operations. I can easily imagine a shelf-switching layout as small as 1 by 10 feet, having frequent passenger train operations with as little as a single DMU, a single pocket track behind the backdrop,
a single on-layout station,
and an hourly shuttle back and forth between the two, predictably and regularly slicing up the switching tracks to mess up the freight crews with a need to keep the main line clear for higher priority DMUs. Remember, all of this on a shelf layout. Just like the real thing, for almost no extra track and only the cost of the vehicles and the platforms, adding a DMU makes the exact same layout much, much busier and therefore more fun to operate. On the higher end, DMUs are used all across Europe for sub-regional or regional level transit. In at least one instance each in North America, DMUs are used in Austin, Texas as a pint-sized old-fashioned commuter rail operation, and in Santa Rosa, California as a de facto intercity passenger train. For a bit more proto-freelancing, DMUs could reasonably be brought to every single layout set after 1980. All of those abandoned stations that sit line-side in every Midwestern small town on BNSF and UP, why not reactivate them with a light passenger train that passes every 2 hours to the nearest big city? All of those less than Union stations in mid-sized cities that have too many house tracks because of the loss of RPO, REA, or other business car traffic, why not convert them into tiny termini for a bunch of 1- and 2-car DMU trains running on several different on- and off-layout routes to provide regional rail transit? Model an entirely rural line composed purely of bridge traffic and a single Amtrak train a day? Why not connect all the ultra-tiny towns on the layout with the daily Amtrak service, which passes through without stopping, by running a DMU shadow ahead of and behind the Amtrak train and making a cross-platform transfer at an intermediate nodal station? An example of the latter idea to get the point across, Cresson, Pennsylvania has the Station Inn, an incredibly famous little rail fanning destination, and while the Amtrak Pennsylvanian passes right through Cresson, the nearest station stop is 50 kilometers away in Altoona, thus not actually making it possible to get to the Station Inn by taking a train without very illegally Tom Cruising your way off the Pennsylvanian by wresting open the door, jumping, tucking, and rolling. As such, every layout of the Horseshoe Curve post-Pennsy is boring as shit and completely copy and pasted from each other, with only 1, maybe 2 passenger trains a day, otherwise depicting a bland industrial conveyor belt indistinguishable from any other freight layout but for the color of the locomotives and that one big curvy bit. However, if such a layout had a DMU service with timed transfers to the Pennsylvanian, offering a shadow local service along the exact same territory and stopping not only at Cresson but also in Portage, Gallitzin, Bellwood, Mount Union, and every other small town along the way, it would both increase traffic along the line for more fun and busy operating sessions, as well as offer car-free and therefore woker transportation to these destinations. As far as models go, this is both the easy and the hard part. For one, as I'm certain you can remember from me talking about before, Pico has released models of the NCTD Sprinters, Siemens DeZeros, which run back and forth between Escondido and Oceanside in Southern California. So we do have at least one DMU whose prototype does in fact run on North American rails, available in model form, ready to run with DCC and sound. However, the Siemens DeZero is a bit outdated and decidedly uncommon in the Western Hemisphere, whereas Stadler is the undeniable juggernaut of DMUs in the US, although that is admittedly a very shallow pool. There are models in multiple scales of Stadler's Flirts, Kisses, Winks, and GTWs, basically most of Stadler's lineup. However, they are all European models of European prototypes. This is somewhat positive in a way, because they are produced in paint schemes again so foreign to the US that any North American modeler would likely not recognize them. So if you're proto-freelancing, you can basically shop around for whatever country's national rail operator has a paint scheme you personally find attractive, and the only thing you need to do is simply remove the lettering. On the other hand, if you're prototype modeling, you can still get the vehicle, but you'll probably have to completely repaint the body shell, and keep in mind the sound decoders likely have announcements in it in, I don't know, Czech or Italian. If you do decide to buy a Euro vehicle, be extra cognizant of AC versus DC. Much like Lionel, Märklin uses third rail AC train control, so AC models would have to be completely repowered from the inside out. Most other Euro manufacturers, such as Trix and Pico, use two-rail DC or DCC, which I believe should be all intercompatible with NMRA-style systems. Probably the most actually useful ready-to-run DMU model of all things comes from Hornby. They recently made a DCC sound-ready Greater Anglia Stadler Flirt in 00 scale. Besides some slight differences on the front end, giving it a more French or West German style look than US prototypes, such as with the Siemens Mirio, it's otherwise a bang-on rendition of a Stadler Flirt. 12 axles, 4 coaches, a power pack car in the middle, and again, simple 21-pin connectors for drop-in decoders to give it DCC, sound, and even Hornby's own Bluetooth operating system, like Blue Nami. The only minor problem is that it's 00 scale. A refresher for those who don't know, 00 is 1 to 76 scale, making it minorly larger to HO's 1 to 87 scale, but it uses the exact same track gauge, making 00 slightly out of proportion. The reason for this discrepancy is that British trains have a much smaller loading gauge than the rest of the world, loading gauge being the physical envelope of train you can fit on the rails before it starts striking platforms, bridge abutments, tunnel portals, and catenary wires. So British modelers decided back in the 30s to use the internationally accepted HO gauge, but size up the scale of their trains to be just a bit larger. This means that the Hornby Flirt, while being the closest we have to a perfect prototype, will be ever just so slightly overscale for the surrounding trains. This may not prove to be too huge a problem, but somebody should definitely test buy it and put it next to GEVO's just to see if it works. Otherwise, the Hornby Flirt could simply be used as a stand-in model until a proper true-to-scale prototype can be replicated. A side note on both the Hornby and other flirts, nearly all of the models that I've mentioned depict EMUs, and therefore have pantographs. However, if I were a Proto-Future modeler, which I am, I personally wouldn't clip off the pantographs to make them look like DMUs. Instead, to accurately depict a rapidly increasing segment of real railroading, I'd leave the pantographs on and simply keep them down and undeployed to depict either a hybrid or BMU vehicle. Running diesel locomotives under electrical wires is a horribly inefficient use of energy and resources, so it makes sense to give DMUs a spare pantograph and transformer to cheat on the higher quality energy whenever it runs through electrified territory in urban areas. Alternatively, at any moment now, the US should be getting a huge inswath of battery electric vehicles, and the way that all existing ones recharge is by a pantograph at station stops, the most preeminent example being the Q-Line streetcar in Detroit. So rather than equipping an entire model railroad with catenary wire, a savvy modeler could make just a short stretch of overhead pantorail at station platforms above where the pantograph sits when the vehicle is appropriately spotted to recharge the BMU during a short layover, and then just build the entire rest of the layout without overhead wires at all. It's an actually ingenious solution to both real-world and model limitations. Overall, as far as DMU layouts go, I strongly recommend checking out part 2 of my Modern Modeling Clinic anthology, available as a video on YouTube and conveniently linked on the website's front page, as it goes into much more depth about how operating sessions and track plans would work, using multiple prototypical examples. Moving on to the next transit technology, and stepping away from modern stuff for a moment, we must briefly examine heavy rail. I once had a friend poignantly observe that practically all future subway projects, or at least in the US, would be in places that already have existing subways. There's practically no city left large or dense enough to warrant a subway line that doesn't already have an existing one. That being said though, much like light rail, many subway systems, both here and abroad, often parallel freight rail and have OMF yards right next to the freight yards, basically writing the same playbook that light rail later followed. Seriously, look into wherever you're modeling and note if there are any nearby or proposed subway installations which would warrant a treatment as a scenic or operational feature of your prototype and append it to the layout much as I've described with light rail. Especially now that there are so many subway models coming out from various manufacturers depicting models from New York City to San Francisco, there's less and less of an excuse to not model subways more and better than the aforementioned token below-grade subway fascia vignette. Remember, in almost every system in the world, subways typically have more track above ground than below. In contrast, schnellbahnen are a rather different matter. Whereas, excepting tram-trains, there's been a prototype basis in the US for almost everything else discussed so far, and while the more adventurous and operationally titillating features are mere extrapolations of current tangible systems for fun factor, the existence and operation of frequent regional rail and sub-intercity rail in a mixed freight passenger fashion as typified by S-Bahnen is quite rare. While true regional rail does exist, most preeminently in the New York area, as seen with the LIRR, NJT, and Metro North, they are all passenger-first, freight as a nighttime afterthought, which makes for a much less fun modeling subject, and conversely limits the true extent the regional rail could reach with better compromises. Probably the only best examples I've personally seen of S-Bahnen in the US are the Port Jervis branch in New York, whichever metro line runs bidirectionally daily, and, surprise surprise, the Lansdale-Doylestown line in Pennsylvania, places which are primarily freight yards and routes with even a few line-side industries, and which are distinctly quite far away from their predominant city center, but which nonetheless have passenger platforms and trains every hour or two throughout the day. I especially recommend looking up the track map of Lansdale, Pennsylvania, as it is practically begging to be modeled for how closely knit the passenger and freight trains are to each other, either as a low-floor tram train or a medium-floor S-Bahn. I personally think the 48-inch floor height of high-floor US platforms is unmitigated overkill. So, for sake of argument, imagine a Euro-rural-style regional rail DMU example of service to every small town the railroad passes through, but with a full-on train of at least 4 cars, usually electrified and double-decker, along with slightly more prioritization of large towns with schedules just barely convenient enough for long-distance daily commuting as opposed to more infrequent intercity travel. Imaginably, such S-Bahn routes could be on triple or more track territory, or at least have bypass tracks at certain stations in order to maintain high frequency of passenger operations, but along with flexibility to avoid severe freight interference. Perhaps attempting to illustrate the difference with an inherently imperfect example, a true electrified S-Bahn would be hourly service between Ames and Des Moines, Iowa. A DMU S-Bahn would be half-hourly, but to outlying neighborhoods of just the Des Moines metro area, as with the 10 prototypical US DMUs, but a DMU intercity passenger service, as in unlike the US but more akin to Europe, would be every 2 to 4 hours and serve all the tiny-ass towns between Ames and Mason City. While there is, of course, a broad spectrum of service patterns, and overlapping S-Bahn and intercity trains could confuse to the point of emulating intra-city DMU service on an entire route, this example illustrates the general differences that different types of rail service are attempting to achieve. Now we can get back to things that have a basis in North America. While the long-distance trains are still important and absolutely do deserve a place on every single model railroad, it is more robust intercity trains which I think could be to large layouts what DMUs are to small layouts. The transformative idea here is to think of things as corridors, distinct routes with high frequency, unique branding, and overlapping service types. Think like Amtrak's Illinois service or Amtrak Cascades. This is not just a single token passenger train to traverse the length of the layout merely once an op session with almost no pomp or circumstance, nor even a few random passenger trains to pad the op session for operators lacking things to do between trains. The idea here is that you need to put effort into designing a proper schedule which would be convenient to use if you happen to live on your own layout. Start by linking major cities in your model territory, Chicago to St. Louis or Seattle to Portland in these examples, with departures semi-hourly or better, no fewer than 4 times a day, ideally minimum 6, with at least 1 very early and 1 very late departure to accommodate supercommuters or nightlife day trippers respectively. If you have a long-distance train covering the same corridor, as they quite often do, build the corridor train schedules around it and use the long-distance train as a bonus round-trip frequency. Then move on to minor outlying routes, big city to small town. These can either be branch routes, such as Chicago to Quincy or Grand Rapids, or route extensions, like Seattle to Portland, but then onwards to Eugene, or Chicago to St. Louis, but then the same train set extends onward to Kansas City. These happen less frequently, in real life as few as once a day, but in our ideal model world, maybe thrice daily. These routes should be timed to have transfers at the main stations with the corridor trains, of course with adequate padding to still allow connections even with moderate delays, making it such that people can continue their journey by transferring trains at the main node, a semi-duplicative example here being Springfield to Chicago on the Lincoln service, but then transferring to the Hiawatha to get to Glenview. In such cases as these, you should treat hubs with something called pulse scheduling, or auf Deutsch Tagfahrt. This means that the station sits largely empty for a scale hour or 2, but then there's a huge pulse of incoming trains which all arrive on nearly every platform all at the same time, wait to allow transfers and delayed trains, then they all start departing again around the same time, leaving the station empty once again for the next pulse. In Switzerland, this happens every half hour with layovers of precisely 5 to 8 minutes. In the US, and a lot of people don't know this actually also happens too, in Chicago, but with a much more generous 4 to 5 hours between when all the long-distance sleeper trains arrive in the morning and then depart again in the early afternoon. In model form, you could go either strategy, on the shorter end with 30-minute layovers and more pulses to give operators more time running trains, or on the long end with fewer pulses and maybe 90 minutes of layover to allow operators to bid for new jobs in between. Finally, you should wrap up with non-radial tangential small-town-to-small-town routes, such as a presently hypothetical Champaign-Urbana to Bloomington-Normal to Peoria to Galesburg to Quad Cities line. These not only allow for inter-rural connectivity, obviating the need for car ownership even in rural areas, they also increase resilience of the urban transit backbones. If, say, you're late one day to Champaign-Urbana and miss the train, and there's not another one for 3 hours, but there is another train departing in a few minutes to Bloomington, whereby you could transfer to another train to Chicago and arrive only an hour late, then it acts effectively as a bonus backup trip to Chicago, preventing people from feeling marooned without a train in the event of an emergency. Furthermore, it's a lot easier to divert trains on routes that already have passenger service, so in the event that there's a signal outage, crash, or some other force majeure, a train can keep running just by detouring its route, rather than having the dreaded bustitution. In general, this all means that, when modeling tangential routes, they should be timed for transfers at stations that intersect the main radial trains, much like the aforementioned pulse scheduling. In terms of infrastructure, except for ultra-major stations like New York, Chicago, Los Angeles, Oakland, etc., passenger yards are usually quite a bit smaller than freight yards. While they can be very large, having many short-term storage tracks, long-term house tracks, and train set maintenance buildings, the typical corridor train yard, I would say, is about 2 to 4 tracks with maybe a small building for locomotive maintenance, a structure to wash the train set between runs, and a few non-track buildings for equipment to clean and restock the train set. On the extreme end, the Carl Sandburg and Illinois Zephyr are parked across the river from Quincy in a yard which is a whopping 1 track big. Given that a modern corridor with multiple departures a day, okay, well, in this case 2, but still, uses a yard with prototypically 1 track, I am once more aggressively positive that passenger trains can and should be found on every possible model railroad, as any layout of any size can justify a satellite OMF as small as 1 locomotive and 3 or 4 cars on a single track. Hell, I've been obsessing over DMUs, but I think this paradigm allows even intercity Amtrak trains to fit on a shelf layout as small as 1 by 10 feet. Also, I'll throw in one more wrinkle. While in the US, and even in the EU, there is a bias towards shuttling trains from station to layover yards between runs, probably both to free up limited station infrastructure, restock and refuel trains, and provide schedule padding so that a late inbound train doesn't delay the next outbound train using the same train set, for model purposes, I believe it's quite fair to overrepresent the nonetheless prototypical practice of laying trains over at the station itself. Since most stations typically have a yard's worth of tracks anyway, and are in fact designed to fit entire train lengths, it makes more sense, especially for medium-sized terminal stations, to not have 2 yards when you can get away with just 1, the station itself. While ultra-major stations of course need a yard track nearby, and zero-track small terminal stations with platforms directly on the main line similarly also need a yard nearby to get laying over passenger trains out of the way of the freight trains, the major terminal stations on most layouts should probably have as many tracks as you intend to have passenger trains on the layout at any given time, in addition to staging yard tracks of equivalent purpose. This allows you to use the main station as a de facto staging yard for passenger trains, keeping them out of the way of the rest of the layout when ops are not in session, but for minimal extra trackage. Another Euro tip, you don't have to have a hyper-flexible station, with the latter allowing access to every platform from every possible inbound track. You can instead save yourself a lot of money on turnouts by making platforms dedicated to each train service, such as all the platforms on the front being served by the trains coming from over here, and all the platforms on the back being served by the trains coming from over there. Wrapping up with a few more modeling notes, if you really want a big old train station on your layout but don't have enough space to justify 35 trains per hour, you could just have a bunch of branches that go immediately into staging at a junction just after the main station, then put 1 or 2 operators in charge of filling out the station with a pre-made schedule of inbound trains straight from staging, plus or minus an intermediate station stop or 2, but still giving most of the rest of the main line over to a freight focus. Finally, when it comes to intercity train stations, in the modern world, every single one should have intermodal connections. This could be anything from a few small bus stops just out back of the station building, to a tram or a streetcar, or even a bunch of LRVs, DMUs, and S-bahnen sidling up alongside the main line for a cross-platform transfer. The point here is that, since passenger trains are one part of a much larger transportation system with the purpose of harming cars and crushing suburbia, you have to model continuing connections to the rest of the model world in order to justify the existence of the passenger trains themselves. That's why modeling walk and bikeability around stations is so important, in addition to the operationally impactful modes of DMUs and tram trains. Just as an industry spur needs to serve a factory or a warehouse to work, so too does a station need intermodal connections and walkability to justify its own existence. Moving a step up from intercity trains, we get into the long-distance and night trains. On a layout with hypertransit and Euro-style operations, they could be as simple as just another train, let's be honest, probably in an ÖBB Nightjet livery, that just departs from the main station to staging with very few intermediate stops in the evening and arrives again in the morning. In a very rare exception to the norm, Amtrak long-distance trains are actually an upgrade on operational potential. A topic worth discussing, which is applicable to both long-distance and intercity trains, is the concept of en-route switching, a very common practice in Europe and even in the US on at least 3 trains. While of course train sharing dining cars, parking business cars at random stations, or even express service and rail mail are all things of the past, that doesn't mean that passenger trains don't do switching anymore. The Lakeshore Limited and Empire Builder both split mid-run in Albany and Spokane respectively, sending a third of each train along a branch to Boston and Portland respectively, and the main portion of the train, that is the one with the dining car, to New York and Seattle respectively. Then the next day repeating the operation in reverse and sending the full-length train back to Chicago and Chicago respectively. The Texas Eagle, on which I have now had an alarming amount of experience, including a 10-hour delay at El Paso, actually replicates the days of old by setting out a coach and a sleeper car thrice a week on a station track in San Antonio for pickup by the Sunset Limited to Los Angeles. In a few extreme examples, I believe the Mini Builder between Chicago and Minneapolis and the Mini Eagle between Chicago and St. Louis, Amtrak has even run short-turn coaches which were left behind at various stations by long-distance trains to boost capacity on the daytime segments in the vicinity of Chicago, but not otherwise haul empty coaches all the rest of the way to the end of the line and back over the next few days. Europe takes this modern version of in-route switching to an extreme degree, with many HSR or even regional and S-Bahn trains being composed of two train sets, signing the front half of the train to one destination and the back half to another, but running it connected for a portion of its length to reduce mainline occupancy, then splitting the train set mid-route to go their separate ways, much to the consternation of oblivious tourists. As such, while many modelers bemoan passenger trains as boring filler to op sessions, there is still switching to be had. You could either directly prototypically model or proto-freelance one of these Amtrak long-distance switching maneuvers, or you could try to replicate a Euro-style in-route split. I'm imagining something like two Midwestern or Caltrans chargers back-to-back with 6 venture coaches between, running from a major station on the layout to an outlying node, and then splitting down the middle for a charger and 3 coaches each, both heading onwards but to different destinations on different branches. To my knowledge, end-to-end Amtrak trains splitting like this en route is a 100% unique-to-the-world idea. If I ever see it in my life being modeled on the layout, I will die happy knowing that I've had an impact on this hobby. When it comes to higher speed rail, or HRSR, there's not too much more that's different from intercity trains. However, I can say that a frequent discussion I've had with multiple under 30 and even some under 20 modelers is the fact that the hobby is obsessed with, and I will specifically note, unprototypically slow speeds. I get it, when switching, yes, we often hurdle cars back and forth faster in scale than reality, and yes, making trains run slower can make you take longer to traverse the length of the railroad, thereby making it feel bigger. However, I believe this has been taken to an excess in the opposite direction, with some older modelers demanding speeds slower than would be prototypical on actual main lines, especially passenger-carrying ones. While I will observe that one of the main reasons we all get into model railroading to begin with is because of the basal lizard brain fun of big machines pulling heavy masses very fast, and I note that it would help to make the hobby attract new modelers by at least occasionally leading into the fun of running things fast, specifically by intentionally including a length of track where you're supposed to run at wide open throttle, I will also make a practical prototypical argument for running trains faster, not just an emotional one. A very little known fact that I want to expand on here, it is cheaper to run a fast train than a slow train, and this is because of 2 reasons. First, to maintain a certain frequency, you need to have as many train sets, operators, and crews as will depart every instance of that frequency until the first train departed reaches its destination, turns around, travels back, and is ready to depart from the original station once again. To make a concrete example, say that you have hourly departures on a route that is 2 hours long, ignoring layover for sake of simplicity. To run this route with a departure at every station every hour, you would need 4 crews at any given moment, 2 being outbound and 2 being inbound. However, if you sped the route up to take half the time, being only 1 hour long, you would need half the number of crews to maintain hourly headways. Since personnel is the single largest expenditure of any transit operation, once built, high-speed rail actually saves money on operations because you need fewer crews to operate each rail mile. The second point is that the cheapness of speed is actually a disproval of the myth of frequent transit. The critic will note that, if it takes twice as many crews to run a slow train, then you just simply don't run it as many times, making transit riders suffer while probably funneling more money back onto roads and highways. However, because frequency is freedom, this makes the train less convenient and more people choose other modes, reducing the overall possible ridership and resulting in a higher subsidy per passenger. It costs more and does less good to run a bad transit service than a good one. So, overall, there are hard prototypical reasons to run trains fast, and prototypical modeling should therefore not be afraid of speed. To depict this, I'd recommend modelers invest in a scale speedometer or go to a large club that has one, test the top speed of their models, program them such that the model's top speed is a scale 110 or 125 miles an hour, and then bring it back to your home layout and program all of the other locomotives to suit, such that you know for certain that top speed open throttle is in fact a prototypical speed. Then test the model speed around your layout's main line, note anywhere that seems unrealistic or could cause derailments, but why not take a few long straightaways or areas with broad curves if you have them, and let passenger operators know that you've set aside those lengths of track for top speed operations. Maybe you don't let freight trains barrel down the tracks, but letting a passenger train do so during an operating session is not only fun and feeds a child a sense of giddiness that we all enjoy, it also gives a sense of purpose and gravitas to the importance of the passenger train. The very last style of modern transit up the hierarchy to discuss is high-speed rail. Unfortunately, however, there is not much precedent at all of making an operations-focused layout depicting HSR in any country, but that's probably with good reason. In many ways, HSR is a crossover between traditional train and fucking airplane, serving only major stops for ultra-express routes with long segments of top-speed running. That means limited stations, long rights-of-way, with many tunnels, viaducts, and curves having radii up to 12 kilometers. However, almost more than fast, HSR is designed to be extremely reliable, resulting in minimal branches, limited overlapping services, and unfortunately, but also importantly, no freight interference. I will note, however, that Italy and Japan, the forerunners of HSR in the world, have actually experimented with high-speed freight rail. If roads and highways are hopefully permanently sunset as a hostile and inhumane mistake of the past, traditional trucking will likely also atrophy, and we might actually see an expansion of this HSFR concept. If you want to do proto-freelancing a humongous bit, it would actually be both trivially easy and obscenely fascinating to have a train class above through freights, very fast freight rail, or VFR I'll call it, which entails running freight drags but behind electric locomotives and on HSR lines. Although in practice and prototype, HSR is usually always separate from regular rail routes, so this idea is probably way too crazy for the vast majority of modelers, but it is an interesting one. However, this does not necessarily mean that modeling HSR trains is out of the question. Looking to the German style of HSR, their HSR lines almost always start and end only outside of major cities, much like highways were supposed to before America fucked it up so bad. Almost always, in major cities, ICE-Züge, or ICE trains, exist as HSR routes on the outskirts of a city, then take the same tracks into the same Hauptbahnhof, or main train station, as regular-ass local trains and S-Bahnen. So, while this is much more fanciful and proto-future oriented than the hard and numerous prototypical examples of modern light rail and streetcars being right out front of a main train station, in many ways, the motivation is similar. If you have a medium or large Union station on your layout, there's a damn good likelihood that in 40 years, it will have at least a few electrified tracks and HSR train sets parked upon them. So why wait around for reality to catch up and lock yourself only into the most boring possible modeling option? You can integrate them into the op session as above just by running trains von der Hauptbahnhof to a nearby train station, then nach dem staging yard, heißt auf Deutsch einen Schattenbahnhof, or literally shadow train station. As with every other technology discussed so far, I'll go into a bit more detail on how this could work in the next episode. But before we close out, I do want to use HSR for a moment to point out a few more learning opportunities from Europe, that of train categories. In the EU, on the famous omnipresent blue and white train departure boards found in every train station, you'll of course see things like train number, destination, station callings, departure time, departure track, and any delay notifications, as well as obviously train operator, seeing as there are a gazillion over there, whereas we've only got Amtrak and at best your hometown's regional rail agency. But there will also be the train category, typically preceding or attached to the train number, like RB80 nach Würzburg or ICE1 nach Hamburg-Altona. This is shorthand for the type and level of service that train offers, and as such, their cost. A disclaimer here that there are innumerable exceptions, and what I'm about to say is a gross generalization, but I've read like 40 Wikipedia articles for this, and I generally think it passes muster. On the low end of the spectrum, you have S-Bahnen, designated simply by an S, like S1, 2, 10, and so on. These are regional lines around a city connecting to its neighborhoods, suburbs, and outlying towns discussed earlier, typically short local routes running frequently every 30 to 60 minutes. This is basically just the equivalent of regional/commuter rail like New Jersey Transit, SEPTA, or the MBTA. Not you, Metrolink, you have a shit ton of work to do. Rarely, and in some larger or busier regions, you'll find an express S-Bahn by some local name with an X, such as the RRX, or Rhine-Ruhr Express, in the Lower Rhine region, or the MEX, the Metropolitan Express, in Baden-Württemberg. These are highly multipolar places with a bunch of small cities that grew into each other, and their express S-Bahn services are exactly that, the most major and frequent way to get cross-metroplex, connecting you with as many other lines and major stations as quickly as possible with minimal intermediate stops. There aren't quite any good comparisons in the US, but the TRE between Dallas and Fort Worth, Metro UP North Line between Chicago and Evanston, and of course Caltrain Baby Bullets all get the point across. While I've heretofore been sloppy with my use of the word region in regional rail, for the purposes of the next level up, I'll clarify that S-Bahnen and their expresses serve a metro area and are therefore effectively transit, whereas RB and RE trains serve a region and are better seen as intercity rail. These come every 1 to few hours and are another local express pair. Regiobahn, or RB trains, are the slowest, cheapest, all-stops local trains between cities, whereas Regio Express, or RE trains, are the expresses of the slow-speed routes, skipping minor stations. These are not too different from some major blue state Amtrak corridors, like the Illinois service or Amtrak California. In fact, Metrolink and Coaster from LA and San Diego to Oceanside and Oceanside, respectively, could be considered the local RB trains, whereas Surfliner is the equivalent RE service, skipping many
stations
along the way to provide an express option along the exact same tracks. Whereas Deutsche Bahn's RB and RE are the local and express pairs of the low-speed lines with red trains and white trim, in general, the IC and ICEs are the local and express pairs of the high-speed lines with white trains and red trim. Interestingly enough, in the same way as it was in the 2010s for American teenagers to get vague Japanese adjectives tattooed on their arms, since almost even the 60s, I'm thinking here specifically of Dinner for One, Germans have considered English to be the hip and worldly language, so the actual official names of the high-speed trains are, in English, the Intercity and Intercity Express. ICEs, or ICEs, are obviously the premier intercity high-speed rail routes of the world, but few foreigners are aware of their counterparts, the IC, or the IC trains, which are the all-stop local equivalents, but of all the stations on the HSR route. I will note this is a labored comparison, as there are some examples of REs running on HSR lines, most notably the RE 200 zwischen Ulm und Wendlingen an dem Neckar, and conversely there are ICs that ran on low-speed routes, such as those assigned to the ICT or the TD, as well as the new IC Talgo. But in general, the easiest way to understand these differences is that RBs and REs are the local and express pair of the slow-speed rail routes, and the ICs and the ICEs are the local and express pairs of the high-speed rail routes. The only equivalent to the ICEs in the US is the Northeast Regional and Acela pairing. Wrapping up, there are a few more odds and ends to train categories. ETSE and ETSEs are Eurocity and Eurocity Expresses, which are effectively the same thing as ITSE and ITSEs, but which cross international borders and are coordinated between multiple agencies. I have it on bad authority that ETSE and ETSEs must have station dwell times under 15 minutes, be air-conditioned, have onboard meal service, generally be express higher speed services, and must have multilingual staff speaking at least English, French, or German. NJ, or night jet services, are Europe's primary night trains, basically the equivalent of Amtrak long-distance routes. Since I believe 2016, a bunch of other national rail operators in Europe just completely gave up on night trains and contracted everything over to ÖBB, Österreichische Bundesbahnen, oder, auf English, Austrian Federal Railways, because they just ran an unquestionably superior night train service forced in part by Wien's or Vienna's incredible isolation from the rest of Europe. Finally, there is also a classification which partially predated HSR called IR, Interregio, or interregional trains, which are full-on cross-country intercity trains which just happen to use slow-speed routes, distinctly similar to almost every Amtrak train. And with that, I have taken you through almost every single imaginable type of modern transit, from walk and bikeability to high-speed rail, American-style light rail and streetcars to European stadtbahnen and straßenbahnen, the differences between intercity and night jet trains, and the fanciful transit utopias of tram-trains and S-bahnen to the practical incrementalism of DMUs and higher-speed rail. As far as I'm concerned, my thesis statement for this episode trilogy is that so long as there is any named town with any form of local business district on your model railroad, it absolutely must have a walkable, bikeable station with at least thrice daily or more intercity passenger trains, as well as local rail transit service chosen by cycling through all of the available types of passenger train until you find one that fits the size of the town and its demanded service level. I distinctly believe that a large portion of all of these rail transit options are immediately prototypical, and those that aren't yet will be toot sweet. Furthermore, they don't just represent good prototypical practice, many are also good model railroading practice too, allowing you to have more dense, dynamic, varied, animated, and visually distinctive layouts from both the perspective of modeling as well as from the perspective of layout operations. Frequent passenger trains of many flavors are unignorably prototypical and specifically interface with freight trains. As I've said many times before, just as switching areas or intermodal facilities generate traffic for freight trains, so too do local transit systems like light rail and streetcars generate traffic for intercity passenger trains. And similarly, just as warehouses, loading docks, and junk piles sell the realism of an industrial area, so too do cycle tracks and pedestrianized areas sell the realism of train stations. Put simply, ignoring car-free, rail-based transit is just bad modeling. This is honestly the whole reason why I started this damn podcast, because once you see the world in this way, you can't unsee it. Car brain is everywhere, and now non-consensually infests my entire life. I'm ashamed of my nationality and wish to change it specifically because of cars. Tronald and his voter goons were merely the straw that broke the camel's back. So long as walkability and train subsidies are near exclusively the domain of one end of the US political spectrum, then trains are inherently political, and thus so too are their models. To be a model railroader in a vacuum of nostalgia is literally unprototypical, and to be a voter in the US and not support car-free transit and urban density is not just unrealistic, it is intellectually dishonest. But if we flip this around and use our same impulses to make cozy, nostalgic model railroads to instead depict a little science-backed utopia, the world as it ought to be, then we can actually use our tiny trains as a force for good, generating art that gets the point across in miniature, making tangible illustrations of the improvements which could be brought into the real world. I think this makes for not only selfish improvements in model operations enjoyment, but it can also imbue our work with a grand sense of purpose, using our model efforts to benefit the real world as well. This has been episode 19 of the Proto-Future podcast, How to Model Modern Transit Part 2, Passenger Trains on Shelf Layouts. The theme music is Spark of Life by Benjamin Lazarus through Tribe of Noise. I would like to thank my extremely generous and patient patrons Pedro Reyes, Ron Kleiss, Bill Ford, Linda Eskin, Roger Coleman, Billy Brown, Joshua Hoffman, and Tracy Boyd. If you would like to know more, you can visit the website at www.bgtmrring.org. That's Bravo Golf Tango, Michael Romeo Romeo, Indigo November Golf, Oscar Romeo Golf, to listen to the trailer, manifesto, and prologue series, watch the Modern Modeling Clinic anthology, or read the free-to-access Patreon production blog, and please consider donating as little as $1 an episode to help defer hosting equipment and travel costs and support what I do. This content is CAN-credentialed. You can report instances of harassment, abuse, or other harm to their hotline at 617-249-4255 or on their website at creatoraccountabilitynetwork.org. To the best of my knowledge, this is entirely free of content generated or modified by AI and may not be used for algorithmic training. This podcast was written, recorded, and produced on the ancestral lands of the people of Mexico. I would like to thank them for their kindness in accepting me as a refugee from a fascist regime. Thank you very much for listening. Keep riding trains, keep punching Nazis, and keep building a better future.